There are 14 mountains on Earth that exceed 8,000 meters. All of them are located here in the Himalayas. And one rises above all others, Qomolangma. Standing more than 8,800 meters tall on the southern edge of the Tibetan Plateau, it's out of the reach of most of us. But is well within our influence. Never before have its glaciers been receding at the speed seen today, nor have pollutants in the air, river, ice, and snow samples been found at current levels. The most remote corner of the planet is bearing the brunt of climate change, so much so that it's threatening our very own existence. To understand the extent, hundreds of scientists from research facilities across China have been carrying out the most comprehensive study of the mountain in decades. We tagged along as a small team of glaciologists retrieved ice cores from 6,500 meters above sea level. Qomolangma Base Camp, 5,200 meters above sea level. Most of the time, it's a barren wilderness with little more to it than rocks. But once climbing season arrives in the spring, it transforms into a busy hub, attracting mountaineers of the most daring kind and, occasionally, a few hardy scientists. From here upwards, a treacherous journey on jagged rocks. Supplies and equipment carefully loaded onto yaks, each carrying no more than 40 kilos. Every step is an effort for both us and the animals. Our destination is one of Qomolangma's biggest glaciers.
这是冰川，叫东绒部冰川嘛，在6500米的一个垭口。
It's a dreamy land, one that makes the bitter 2-day climb worth all the while. But the scientists in the group aren't happy with what they're looking at.
肉眼看出来就是这个冰川的消融太强烈了，而且导致了整个这个地形地貌都发生了非常强烈的变化。
The team last retrieved ice cores from this part of Qomolangma in 2018. They want to drill deeper this time, all the way to the bottom of the glacier.
冰芯里边其实能记录好多东西，
非常多，特别是自80年代、90年代的关于全球变化兴起以来，冰芯研究就是取得了不可替代的地位。关于温室气体增长越来越高的这种发现，温度的增温的发现，一系列发现，都来自于极地冰芯的研究。
Ice cores are cylindrical blocks of ice removed from a glacier. They are one of the most vital tools to study past climate. Millions of years of snow accumulate on top of each other, compressing into ice under its own weight. Each layer is different in texture and chemical makeup, like a series of tree rings corresponding to years and seasons. This allows scientists to reconstruct climate far into the past.
只要我这个冰芯能记录多久就恢复多久，是10万年、几十万年甚至100万年尺度都可以。比如说它自身的同素的变化，就反映它凝结时候的大气的温度。我们利用同素来恢复历史时期的温度变化， 就类似于气象记录一样的。
Isotopes, different versions of the same atom. Oxygen, for example, there's the common O16 containing 8 protons and 8 neutrons. And there's the heavy oxygen, O18, with 2 more neutrons. Turns out, the ratio of heavy to light oxygen in ice cores is a good indicator of past temperatures. The same goes for hydrogen isotopes. Scientists like Professor Xu Baiqing can read it like a book.
所以冰芯对您来说是一个特别有意思的。
对，它是一个宝库，可以说，只要我们能够想象到的，只要你手段够先进，你敢尝试去分析的，你都能有所收获。所以说，它是一个大自然的博物馆，应该是。
To access fresh water, we camp out on these rocks. Even though it means painful trips to the coring site. First, up and down through a forest of towering ice pyramids. Then onto a snow slope, equipment on the backs of younger members of the team.
我现在拉的东西有300多斤，现在身体呼吸有点难，累是累一点。
The oxygen level here is only 45% of sea level norms.
要扎在那个最远的那个最高的那个天际线那块。
So it took us 4 hours to get there, a distance of only about 5 kilometers. But there's one problem.
已经到顶，但是这附近很多裂隙，咱们要找一个比较合适的地方。
Crevasses are dangerous cracks in the ice,
这个就是什么？
which are often difficult to spot under the deep cover of snow, potentially lethal to both the coring operation and us.
重力作用，冰川向下运动，挖开了，挖了几十米宽呢。
几十米宽。
对，甚至上百米宽。
It's a harsh and dangerous environment, with glacial ice constantly on the move, and blizzards well capable of uprooting tents. Scientists are only able to work here for a few weeks each year.
你看我们搭个球形帐，这叫，是吧？我们那个钻探的设备啊，全部在这个帐篷里面，都竖起来，然后呢就在里面可以工作了。
As light gives way to darkness, the real work begins.
我把这个所有螺丝也看一下，它的电机螺丝，我看它的检查。
Coring on the Tibetan Plateau usually takes place at night to protect the samples from the unrelenting sun.
开了啊，开，注意放到正中间啊。
The drill barrel has tiny little teeth at the bottom. As it rotates, it carves out the ice. The core is left in the middle.
75到80。
Each drill brings up about 70 to 80 centimeters of ice.
72.5。0到16。
Scientists catalog the sections, carefully documenting their physical characteristics.
这边靠叶，现在是渣子吧？是渣子吗？
The samples will be dated, studied, and analyzed for years once they're shipped down the mountain. Or melted right away for warm drinks against the cold. This sip comes from snow that fell about the time electricity was discovered. We have a long night ahead of us. Professor Xu Baiqing and his colleagues returned to East Rongbuk as part of China's second Tibetan Plateau scientific expedition, or STEP. The first one started back in the 1970s. In the decades in between, the Tibetan Plateau has lost a fifth of its glaciers to global warming. And the speed of melting is only accelerating. This image was taken by the NASA Earth Observatory in 1987. It shows a small patch of terrain in a central part of the Tibetan Plateau. This is what the same area looked like in 2021. Halfway up the world's highest peak, far from any human presence, scientists are rushing to save what could soon be the last remaining samples of our planet's ancient past.
这段路实际上是我从01年、05年、18年到现在来回跑了好几趟，印象最深刻的是越来越难走了。原来你看嘛，实际上我们从那个营地直接就是上到地面的，现在都是大型的那种湖泊呀、什么河流啊，人都是上下的很危险的一种路程，才能到达我们的那种冰面上。所以说这个路现在是越来越难走，也表现冬融冰川的消融强度是越来越强。
The effect of melting is everywhere to be seen and experienced. Shortly after setting off from camp the next day, glacial lakes flooded our path to the coring site.
它这个湖啊，一个个都是靠冰作为坝的，融这个坝一溃以后，这个湖就全部灌在这里面了。这水位那个涨起来快点。这肯定走不了，那水太大了。走不了，那水太大了。只能从上面看看找到，能不能找这个过去的小水道。
We sent up a drone to find a different way. When none was found, the team tried chipping out footholds in solid ice.
焦虑啊，这个肯定耽误时间啊。而且我们这条路也还不知道能够支撑多久，也许会每天都要修。
But at least for today, it was enough to get us going again on slippery and almost vertical ice.
中国关于青藏高原研究的发端实际上是自1980年代末。那么第一个明星是俄亥俄州立大学劳伦汤普森教授和我们双方，在我们祁连山登德冰帽站出来第一个明星。
Professor Lonnie Thompson belongs to the generation of climate scientists who brought world attention to the issue of climate change.
It was the very first course to come out of Tibet. You know, our first project there was, can you do it? Can you actually drill this part, get the ice cores, keep them frozen, and get them from Western China all the way across China to Beijing, and keep it frozen? So we were learning a lot in a very, very short period of time. But for the very first core, it kind of opened the door.
Over the decades, Chinese scientists have extracted more than 20 ice cores from multiple locations on the Tibetan Plateau. Professor Xu Baicheng has personally drilled 12. Through data trapped in ice, he studies the formation of the climate, specifically the movement of air called atmospheric circulation. And the colossal presence of ice and rock that forms the plateau is a driving force of that movement.
现在我们很多气候学家把青藏高原结为气候引擎，它是触发了一系列的气候的环流。驻大的青藏高原，驻大的海拔高度，处于在中纬度地区，这不但呢引起了气候系统的变化，就导致了复杂的全球气候系统类型。
Here's how. In the summer, the elevated plateau receives more energy from the sun. The air above it rises from the heat. This creates a low pressure area which sucks in air from its surroundings. The monsoon gains force, bringing with it air full of moisture from the Indian Ocean.
从南亚到东亚，北纬23度， 到30度左右这样一个，本来这个地区应该是副热带高气压带，是极度干旱的全球一个干旱带。但是现在这个带在亚洲地区的这一个带形成了鱼米之乡，降水丰沛的，这是由于青藏高原加强了季风系统的最重要的佐证。如果没有青藏高原，可想这是一条横贯整个全球的一条可以说死亡之带、沙漠之带。
This is where Asia's weather is made, and where its greatest rivers are born. It is also home to the largest number of glaciers outside of the polar regions, hence the name the Third Pole. Frozen here, a fresh water resource which sustains a fifth of the world's population. Also frozen in time, tiny pockets of air trapped in ice like an ancient fly in amber. With it, airborne particles like pollen and volcanic ash.
那么我1000年前的冰，它包裹的是1000年前的气体；我3000年前的冰，包裹的是3000年前的气体。我只要把什么年代的冰的气泡打开了，我通过分析手段，我就知道那时候的大气的成分是什么。所以说，通过冰心气体的研究，我们可以进行全球尺度的，像水循环研究、生态系统里面的像碳氮循环研究，以及我们现在全球变暖背景下的温室气体研究。像我们是如何得知过去200多年的大气温室气体的含量越来越高、越来越高呢？还是从冰心里面。
Scientists only started to measure levels of CO2 in the atmosphere in the 1950s. But bubbles in ice cores were able to extend the record way back.
Eventually, we ended up with a record of these gases going back 800,000 years. And when you trace the temperature of the planet over that period of time, you go from warm periods like we're in now to ice ages and back to warm periods. And every time you go into a warm period, carbon dioxide goes up. Every time you go into a cold period, it goes down.
Up and down between 170 and 300 parts per million by volume. That is, before industrialization. So where are we now?
Today, we're up to almost 420 parts per million by volume. We have never seen levels that high in that 800,000 year history. And that's why people are concerned.
Compounding the issue, aerosols. Tiny flecks of matter in the air which often end up trapped in ice cores. Near camp, the team installs the world's highest black carbon monitoring station. Black carbon is the fancy name for soot. Like CO2, it comes from burning fossil fuels, wood, and other sources of biomass. It's the number 2 contributor to global warming.
降在这个雪冰表面，它能够使雪冰这个用通俗的话来讲，就是它的这个颜色发暗。这样的话，它会吸收更多的这个太阳辐射，促进了这个雪冰的这个消融。
This is like wearing a black T-shirt on a sunny day.
因为我们从2018年观测到了一个比较有趣的现象，所以通过这个现象推测了它的一种传输机制。但是当时的观测只有4天。
Scientists have long known that even the Himalayas couldn't stop some soot from getting here, but not the amount they saw in 2018. They want to find out exactly how the particles traveled this high and what it means for the glaciers here. There's another type of aerosol that can end up trapped in ice cores, one that's rather mysterious. Dust. Swirling up the world's deserts and blown by wind across continents, dust cools our planet in some cases, but warms it in others.
因为它的那个粒径大小啊，正好是以那个上升为主的，就是说能够把这个太阳到达地面的太阳辐射很大一部分这个反射回太空，也就是说它就有一个制冷效应。
But then again, there's the black t-shirt effect. Dust darkens the ice and snow, making them more susceptible to melting. But surely, one effect must have a greater influence than the other.
全球变暖这一块是整个人类社会都在关注的一个问题，但是这个变暖它的机理是什么？它又产生什么样的具体的一个环境效应？这一直是我们这个长期的一个研究的内容。
There's a sense of urgency in the work on the Tibetan Plateau because the region is warming faster than most other places on the planet.
青藏高原温度它上升的速率是全球平均的2倍。
The global average is about 0.17 degrees Celsius per decade. On the Tibetan Plateau, 0.35 degrees.
"青藏高原来说啊，它是整个亚洲水塔的聚集区。那么呢，这是这个水资源问题，还有一个灾害问题。你冰川加速走它本身会形成很多灾害，像我们近期频繁发生的冰崩啊，像冰湖溃决啊、冰川洪水呀、冰川泥石流啊等等等等。
Indigenous people who live in these regions next to the glaciers, they're the first, they're on the front line. They see the changes in water discharge coming from the glaciers. They see the loss. Glaciers are sacred places. They're places where their gods live or their ancestors live. And so their whole belief system is being tested with the loss of those glaciers.
And after the initial blow on the locals, it's all of us.
We've never had 7.8 billion people on the planet. All those people depend on a stable climate for food, economies, social interactions, everything that we do. When we start changing that climate, then we put all of these things that humans value at risk.
It took the team 4 nights to drill to the bottom of the glacier. Altogether, these sections of the core are 110 meters long. The bottom layers estimated to be around 1,000 years old. Local villagers were hired to carry the cores down the mountain on their backs, again after sundown. There's one more thing left for us to do. The temperature of the borehole offers yet another window into past climate. Under normal conditions, the bottom of the ice, heated by the Earth's geothermal energy, should be warmer than the top. But once again, scientists discovered an anomaly. As if more evidence is needed on the toll of climate change here, the surface ice has warmed up to be 3 degrees higher than the base. These massive rivers of ice, built snowflake by snowflake from ancient skies, are turning into what scientists call temperate glaciers. Glaciers that are essentially at melting point.
This is very much like having a parent or child that has terminal cancer. You go and you document, you watch, you feel sorry for what you're saying, but you can't stop it.
那么呢，随着冰川的这种快速的退缩，那么我们不得不去思考这一个问题：如果说青藏高原没有了冰川，那么它发育的这条大江大河，以及富裕的这广大地区的工业输水啊，或者人们生活输水，会出现什么样的情景？